Assalamu alaikum. My name is Hamza Rahman and I am doing my bachelor's in mechatronics engineering. So today our topic is 20 components used in electric circuits. So let's start. So the first thing that we are discussing is carbon film resistor. So first we will discuss what is a resistor. Resistor is a device that restricts or limits or opposes the flow of charge or the flow of electricity that is flowing in a circuit. So, resistors, now we'll discuss where a resistor is used. Resistor is used where we want to give some controlled amount of current that is needed in a circuit. Carbon film resistor is a type of resistor. We use carbon film resistor in electronic appliances and toys, etc. We use carbon film resistor where the cost is more important than the precision or size. A carbon film resistor is made from a ceramic rod coated with a fine layer of carbon film that conducts electricity with some resistance. A helical groove is cut through the film, leaving a long, narrow path of carbon that corkscrews from one end of the rod to the other. Metal caps are crimped onto the two ends, and while leads are added. The resistor is then dipped in a protective coating and painted with color-coded stripes to indicate its resistance value. Resistors of this shape are called axial through-hole resistors, meaning they have wire leads intended to go through holes in a circuit board arranged along the resistor's axis of symmetry. Here you can see a real life image of a carbon film resistor, and here is a diagram. You can see that carbon film coating around the resistor, and inside there is ceramic rod. Here you can see a cross section of the carbon film resistor. This is a real life carbon film resistor, and this cross section is made by rubbing a sandpaper through very precision and applying a little bit of pressure and rubbing it. This is the inside view of a real life carbon film resistor, and here you can see the outer protective coating of the carbon film resistor has been removed. So what are the characteristics of a carbon film resistor? Resistance ranges from 1 ohm to 10 mega ohms, and its tolerance is 1% to 5%. Power rating 1 by 8 volts to 2 volts. Operating temperature is minus 55 degrees Celsius to 155 degrees Celsius. And the last one is low noise and stable performance. Its advantages are low cost, small size, high stability, low temperature coefficient, and suitable for high frequency applications. But it has some disadvantages like limited power handling, susceptible to moisture and humidity, and it may experience drift over time. Now we'll discuss the second component, that is high stability film resistor. The high stability film resistor is about 4 millimeters in diameter and is made in much the same way as its inexpensive carbon film cuisine, but With exacting precision, a ceramic rod is coated with a fine layer of resistive film, and then a perfectly uniform helical groove is machined into the film. Here you can see that the resistor is coated with a glass, and a glass is the ceramic rod is coated with a thin glass layer. Instead of coating the resistor with an epoxy, it's hermetically sealed in a lustrous little glass envelope, as I mentioned. This makes the resistor more robust, ideal for specialized cases such as precision reference instrumentation, where long term stability of the resistor is critical. The glass envelope provides better isolation against moisture and other environmental changes than standard coating like epoxy. The third component we are going to discuss is a wire wound power resistor. As current flows through a resistor, the resistor converts a certain amount of electrical energy into heat. Most general purpose resistors have little ability to dissipate heat as they cannot withstand elevated temperatures. This limits the amount of power they can handle. Power resistors like this one is made without temperature limiting materials like solder and epoxy, enabling them to handle more power. Some power supplies use them to limit the rush of current that occurs when you plug them in. The active element is a resistive metal wire wrapped around an insulating core. The resistive assembly is placed in a heat tolerant ceramic shell and filled with cement grout. Here you can see a cross section of a wire wound power resistor. A wire wound power resistor is a type of resistor that uses a wire winding to provide resistance, designed for high power application. Its advantages are it can handle high power, it is low inductance, it has high stability, it is suitable for high frequency applications, and it is cost effective. The disadvantages are large size, limited precision due to winding, potential for thermal drift, and may experience noise and vibration. And it is used in some of the applications like power supplies, motor control, audio amplifiers, medical equipment, industrial control system, and electric vehicles, etc. The fourth component we are going to discuss is thick film resistor array. A thick film resistor array is a type of resistor network that integrates multiple resistors on a single substrate using thick film technology. It is constructed by resistive material deposited on a ceramic substrate. It is also constructed by screen printing or photolithography for resistor pattern creations, and high temperature firing for stabilization, and metal leads or terminals for connection. Many circuits require multiple identical resistors. For example, a digital data bus might need a termination resistor connected in series with each data line, or each I/O pin on a microcontroller might need a pull down resistor between the pin and ground. A resistor array eliminates the need of multiple discrete resistors. It consists of several resistors fabricated as a single component. Shown here are thick film arrays named from the fabrication technology which uses silk screen conductive and resistive film that are fired like pottery glazes into a ceramic substrate. After metal terminals pins are fitted and soldered, a laser burn away part of the resistive material to fine tune each individual resistor to its correct specification. Finally, the array is dipped in an epoxy coating for protection. Here you can see a cross section of the resistor, and the thick film resistor array is like this from a close-up view. This is a single inline resistor array or SIL where all the terminals are arranged in a straight line. It has four independent resistors that aren't connected to each other. Now the next component is a wire wound potentiometer. A wire wound potentiometer is a type of potentiometer that uses a wire winding to provide a variable resistance allowing for precise voltage division. A potentiometer or POT is an adjustable resistor. We can use it if we want to adjust some resistance by rotating the knob that is available. Pots are used as front panel control knobs on everything from laboratory instrumentation to guitar amplifiers, anything where you turn a knob to adjust a setting. This large pot is made of resistive wire wrapped around a ceramic form, an old design essentially unchanged since 1925 and still in production today. There are two terminals connected to either end of the resistive wire, and a third terminal is connected to a spring loaded contact called a wiper. The wiper touches the wire winding, making an electrical connection that can be moved around by rotating the shaft. As the wiper moves away from or towards a terminal, the resistance between the wiper and the terminal increases or decreases because electrical current has to flow through a different amount of resistive wire, and an amplifier circuit translate this changing resistance into a louder volume, or a hot plate interprets it as a temperature set point. Its applications are audio equipment volume controls. The second one is industrial control systems. The third is medical devices. And fourth, we can use it in automotive systems. And the fifth can be aerospace and defense system. Its advantages are high precision and resolution. The second one is low noise and thermal drift. And third can be high reliability and durability. The fourth can be suitable for high frequency applications, but it has some disadvantages like limited life expectancy and susceptible to vibration and shock. The third, it can experience contact resistance errors. Here you can see a cross section of a wire wound resistor, wire wound potentiometer. The next component is a 15-turn trimmer potentiometer. A 15-turn trimmer potentiometer is a type of potentiometer designed for precise adjustment and calibration requiring 15 turns of the shaft to move forward from minimum to maximum resistance. Its characteristics are that number one, the resistance range is from 10 ohms to 100 kilo ohms. The second one is its tolerance, that is from 1% to 5%. The third is the number of turns, that are 15. The fourth is rotation angle, that is 360 degree into 15, that is 5400 degrees. Operating temperature is minus 55 degrees centigrade to 150 degrees centigrade. The sixth one is high reliability and durability. Now we'll see that it takes 15 rotations of an adjustment screw to move a 15-turn trimmer potentiometer from one end of its resistive range to the other. Circuit that needs to be adjusted with fine resolution control use this type of trimmer pot instead of a single turn variety. The resistive element in this trimmer is a strip of cermet silk screen on a white ceramic substance. Screen printed metal links each end of the strip to the connecting wire. It's a flattened linear version of the horseshoe shaped resistive element in single turn trimmer. Turning the adjustment screws moves a plastic slider along a track. The wiper is a spring finger, a spring loaded metal contact attached to the slider. It makes contact between a metal strip and the selected point on the strip of the resistive film. Here you can see a real life image of a 15 turn trimmer potentiometer, and this is a cross section of it. Here you can see there is a ceramic substrate and an epoxy fill. These three are the terminals. This is an adjustment screw that you can turn and adjust the potentiometer. This blue one is a plastic case and plastic coating around, and there is a wiper and a cermet strip. Here you can see a close up view of a real life potentiometer, 15 turn trimmer potentiometer. The next component is a ceramic disc capacitor. A ceramic disc capacitor is a type of capacitor that uses a ceramic disc as the dielectric material, providing a compact and reliable solution for various electronic applications. It is constructed by a ceramic disc as dielectric. Number two, a metal electrodes on both sides that can be silver or gold. The third is encased in a protective coating that can be epoxy. The characteristics of a ceramic disc capacitor are that its capacitor ranges from 1 picofarad to 100 nanofarad. Voltage rating is 5 volts to 1000 volts. Tolerance is plus minus 5% to positive negative 20%. Fourth is operating temperature, that is from minus 55 degrees centigrade to 125 degrees centigrade. Low inductance and ESR. ESR means equivalent series resistance. Now we'll discuss that it is a type of capacitor. So we'll discuss what is a capacitor. Capacitor are fundamental electronic components that store energy in the form of static electricity. They are used in countless ways, including for bulk energy storage, to smooth out electronic signals, and as computer memory cells. The simplest capacitor consists of two parallel metal plates with a gap between them. But capacitor can take many forms so long as there are two conductive surfaces called electrodes separated by an insulator. A ceramic disc capacitor is a low-cost capacitor that is frequently found in appliances and toys, etc. Its insulator is a ceramic disc and its two parallel plates are extremely thin metal coating that are evaporated or sputtered into the disc's outer surfaces. Connecting wires are attached using solder and the whole assembly is dipped into a porous coating material that dries hard and protects the capacitor from damage. Here is a ceramic disc capacitor. Here you can see the diagram and a cross section of the capacitor. This is a plastic foam coating. The wire leads are these two. These are the metal electrodes, and this is a ceramic disc, and this is a solder. Here you can see the real life cross section of a ceramic disc capacitor. Now we'll discuss the application where the ceramic disc capacitor is used. The number one, it can be used in audio filters and coupling. The number two is RF and microwave circuits. The number three is power supply filtering. Four is medical devices and implants. Five is automotive and industrial electronics. Its advantages are number one, a compact size. As you can see, it is very small in size and very thin. The number two advantage is it has low cost. Third is high reliability. Fourth is low inductance. And number fifth is suitable for high frequency applications. It has some disadvantages like limited capacitance range. Number two is voltage limitations. Number third is temperature coefficient errors. The next component is a glass capacitor. A glass capacitor is a type of capacitor that uses glass as a dielectric material, providing high reliability, stability, and temperature tolerance. It is constructed with three components, main components. Number one is glass dielectric material that can be borosilicate or quartz. Number second is metal electrodes on both sides that can be silver or gold. Number third is hermetically sealed in a glass enveloped. The advantages of glass capacitor are high reliability and stability. Second is low loss and high Q factor. Third is high temperature tolerance. Four is non polar and non-reactive. Fifth is suitable for high frequency applications. The disadvantages are higher cost compared to ceramic or film capacitor. Number second is limited capacitance range. Third is larger size compared to ceramic or film capacitors. Number four is fragility due to glass construction. Here you can see a glass capacitor, and this is the close view picture of a glass capacitor. The next component is a multi-layer ceramic capacitor. A multi-layer ceramic capacitor is a type of capacitor that uses multiple layers of ceramic dielectric material and metal electrodes to provide high capacitance, density, and reliability. It is constructed by three main components that are multiple layers of ceramic dielectric materials that can be barium, titanate. The number second is metal electrodes that can be nickel or copper. The number third component is that it is encased in a protective coating that can be epoxy. The MLCs CCs are surface mount chip capacitors consisting of interleaved layer of deposited metal between layers of specialized ceramic. This one shows is a cross section. The one shown here in cross section is 1.5 millimeter long and has five interleaved metal layers with, with two layers connected to one terminal and three to the other. This may have thousands of layers in a device of same size. Advantages are high capacitance density, low inductance, high reliability, small size, and cost effective. Disadvantages can be limited voltage range, temperature coefficient errors, may experience cracking or flexure. Characteristics are that capacitor range from 1 picofarad to 100 microfarad. Voltage rating is 4 volts to 1000 volts. Operating temperature is minus 55 degrees centigrade to 150 degrees centigrade. Number fifth is low inductance and ESR. ESR means equivalent series resistance. The next component is aluminum electrolytic capacitor. An aluminum electrolytic capacitor is a type of capacitor that uses aluminum oxide as the dielectric material and an electrolyte to increase capacitance. Construction: it is constructed by an aluminum foil anode, an aluminum oxide dielectric layer. Electrolyte can be liquid or solid, cathode foil, and encased in aluminum or plastic casing. The characteristic of this capacitor is that capacitance ranges from 1 microfarad to 100,000 microfarad. Voltage rating is from 4 volts to 500 volts. Operating temperature is minus 40 degrees centigrade to 150 degrees centigrade, and high capacitance to size ratio. Its advantages are high capacitance to size ratio, low cost, high ripple current capability, and suitable for high frequency applications. Disadvantages are limited lifespan, temperature dependent performance, may experience leakage current, and polarized. That means it requires correct voltage polarity. The next component is a film capacitor. A film capacitor is a type of capacitor that uses a thin plastic film as the dielectric material, providing high reliability, stability, and insulation. It is constructed by a plastic film dielectric. It can be polyester, polypropylene, or polystyrene, and it consists of metal electrodes that can be aluminum or zinc. The third component is that this capacitor is encased in a protective coating that can be epoxy or PVC. The application of this capacitor are it can be used in audio and video equipment, power supplies and filtering, industrial control systems, automotive electronics, and medical devices and implants. Advantages are high reliability and stability, low loss and high Q factor, high insulation resistance, suitable for high frequency applications, self healing properties. Disadvantages limited capacitance range, larger size compared to ceramic capacitors, may experience moisture absorbance, higher cost compared to ceramic capacitors. Here you can see a cross section of the capacitor, film capacitor, and in this is the cross section. You can see the the plastic film is transparent and remarkably thin. You can see through the film because it is very thin. The next component is a dipped tantalum capacitor. A dipped tantalum capacitor is a type of electrolytic capacitor that uses tantalum as an electrode as an anode material and liquid electrolyte to increase capacitance. It is constructed by tantalum anode foil, liquid electrolyte that can be manganese dioxide or tantalum pentoxide. Cathode material can be carbon or silver, and it is encased in a protective coating that can be epoxy or resin. The next material is ferrite bead. A ferrite bead is a type of passive electronic component used to suppress electromagnetic interference EMI or radio frequency interference RFI in electronic circuits. It is constructed by ferrite material that can be manganese, zinc, or nickel zinc. The number second component that is used in the construction is bead shaped core. The third component is wire or lead wrapped around the core. You can see this component in audio equipments, video equipments, computer system, medical devices, automotive electronics, and in power supplies, DC to DC converter, switch mode power supplies. The next component is power supply transformer. A power supply transformer is an electrical device that transfers electrical energy from one circuit to another through electromagnetic induction, providing isolation, voltage transformation, and current regulation. It has some types like step up transformer, step down, isolation transformer, auto transformer, switch mode transformer. Here you can see a cross section of a power supply transformer. The next component is a low power cartridge fuses. First, we'll discuss what are fuses. Fuses are electrical components that break or open the circuit when more than the specific amount of current passes through them, protecting the other components. of the circuit from damage or to break other some other components. Low power cartridge fuses are electrical devices designed to protect electronic circuit from overcurrent conditions, providing a safe and reliable way to interrupt power.
Now we'll discuss a 1N4002 diode. First, we'll discuss what is a diode because this is a type of diode. A diodes are the components that allow current to flow only in one direction, much like a check valve in plumbing. They are commonly used in power supply to converting alternating current to direct current. The diode itself is a tiny chip of silicon, also called a DIE. The otherwise ultra-pure silicon is modified to have separate regions, one where electrical current is carried by electrons and another with holes placed where electrons are missing. The junction between the two regions, the active area of the device, can conduct current only in one direction. The 1N4002 diode is a general-purpose rectifier diode used for converting AC to DC, voltage rectification, and protection against reverse polarity. Here is a cross-section of 1N4002 diode. The next component is LM309K voltage regulator. It is a linear voltage regulator providing a stable and regulated output voltage from a variable input voltage. The LM309K's silicon chip is a large but relatively simple integrated circuit or IC, a circuit made with many sub-components like transistors and resistors fabricated together on a single piece of silicon. Dual inline package, the next component we are going to discuss. It is a type of integrated circuit package that features two rows of pins, typically 14, 16, 18, 20, 24, 28, or 40 pins arranged in a rectangular shape. Integrated circuits can have many more terminals than the two or three on the component that we've looked at thus far. The next component we are going to discuss is a through-hole red LED. A through-hole red LED light-emitting diode is a type of electronic component that emits a red light when an electric current passes through it, mounted on a printed circuit board using through-hole technology. Consistently charming or deceptively simple light-emitting diode or LED are filled with subtle design details. Semiconductor diode in a LED isn't silicon but a tailored semiconductor that emits the desired color of light when active. The last component of today's topic is optical encoders. Optical encoders are sensors that convert mechanical motion to digital signals using light and photodetectors to measure position, velocity, and direction. In modern computer mouse, a low-resolution optical sensor like the one we saw on the page 83 in a thin cord flat back measures the mouse change in the position as we move it around the old-style ball mice. Two optical encoders sense the motion of the physical ball that rolls when the mouse moves. Optical encoders work like an advanced version of the optical tilt sensor, and infrared light shines through an encoded wheel, a wheel with slits that alternatively block or allow the light to pass. The phototransistor positioned on the other side of the wheel detect the light as the wheel rotates. Circuitry in the mouse decodes the phototransistor's output signal to calculate how far and in which direction to move the on-screen cursor. Today, ball mouse are obsolete, but mouse with scroll wheels still use optical encoders to detect the rotation of the wheel. So, guys, that was it. Thanks for watching the video. Allah Hafiz.